Good morning, everybody. It's nice to be here again. Nice to see a few familiar faces. It's always good at this relatively early time in the morning. So, as you heard in the introduction, Internet of Things is something that everybody is talking about, and I thought this was a very good opportunity to give you my, well, in American they would say 2 cents worth. In England we say 6 pennyworth, which is in fact about, 43 years out of date, since we don't have sixpences anymore. So at least Americans are up to date there. I want to give you my opinion, my view of Internet of Things. I use the title Internet and Embedded Software because it's the software aspect that interests me most of all. But of course, when it comes to embedded systems, the mixture of software and hardware is what's really interesting, actually. So although I'm a software engineer and regard hardware as just a necessary evil, it's not something I can walk away from totally. I called the presentation No Change or All Change. I'll explain that title first of all. In fact, I had an alternative title, which I thought was more topical because obviously we're now in the... Again, I draw a comparison with America. In the UK and maybe here in France as well, we're now in the pre-Christmas period, which I find incredibly annoying because Christmas is two months away or so. In America, they have a Thanksgiving later in November. At least that gives them something to aim for, and then they can start thinking about Christmas afterwards. So I concur that over the Atlantic they have something better than we do. So I couldn't really use this title. I go back to the original one. No change or all change. So is Internet of Things a big change, or is it just more of the same? Well, first of all, to explain my wording here, the phrase all change, anybody who is English or is familiar with being in England would know the phrase all change. It's what they say on a train. When a train is coming to a terminus and there's nowhere else to go, you've got to get off the train. The guard on the train would shout out, all change, all change. It's a very familiar sound to us. And it really means everything's got to change now, whether you like it or not. You're not going anywhere further. So, is Internet of Things a terminus as well? I want to talk about fashion, first of all. Now, we may not be in Paris, but we are in France, so it's a country where fashion is considered quite important. And, of course, embedded software engineers are very fashion-conscious people. I illustrate this with shoes, because that's a nice, easy thing to understand. Actually, I will be in trouble with Gabriele if I don't take into account all possibilities when it comes to embedded software engineers. They're very fashionable kinds of people. Actually, they're not. Most software engineers are perhaps, shall we say, less conscious of fashion when it comes to clothes and things like that. But they're still fashion conscious in a different way. What I'm thinking of here is that I've worked in this business a long time. I've spent a lot of time at conferences. I've spent a lot of time talking to people. I know what interests people at a particular time. And it changes from time to time. Here's a little list of technologies and products which have been the great white hope over the years. Each of these has been a subject which has been on everybody's lips for a period of time, typically a couple of years. So for a couple of years, C++ was the language that everyone is going to use for embedded software. It was the future of the business. Was it the future? No. C++ is used, it hasn't gone away, but it hasn't completely replaced C. Windows CE was going to be the operating system for just about all embedded applications. No, it isn't. It's still around, it's still used in its various forms. And I carry on down the list with Java, Eclipse. These are all things that are widely used, but they've never become the thing and changed the industry totally. UML as well. LowPower Design is an interesting one because it's not a single technology, it's not a single product, it's more of a trend, but something everybody said that was going to be a concern to all engineers all the time. And low power design is quite important and continues to be, but it's not the hot topic, because guess what? The hot topic today is the Internet of Things. So I'm not going to say to you that the Internet of Things is just a fad that's going to go away. But I'm suggesting that it's not the future, it's not the only future, it's not the only possibility here on. I don't believe it's a disruptive influence on the industry or anything of that nature. It is simply a logical point to be, and it's something we're talking about now. So now I want to poke around this technology and have a look what it all means. Having sort of talked it down a little bit, let's talk it up again. I want to talk about home automation. Home automation is an example of the Internet of Things. And then I'll show you some non-examples, and we'll see if we can figure out actually what the Internet of Things is. Now, in order to talk about this particular topic, I need to introduce somebody else. I need to introduce you to my wife. Unfortunately, she is not able to be here today. She's too busy doing something else. But I have a picture of her, so this is Libby. And she doesn't normally attend conferences with me, but she is very interested in the Internet of Things. I don't think she knows she's interested in the Internet of Things, but you'll see what I mean. Now, Libby and I live in England. English weather is, as you know, somewhat unpredictable, and it never gets too cold, it never gets too hot. It's always a little down the middle, but on winter days it can be a bit cold, and Libby does feel the cold. So the solution we have is, when you go to bed at night, you get into bed and it's very cold in between the sheets, and she doesn't like that. So we have an electric blanket, one either side of the bed. You switch it on, it gradually gets warm. It's very nice. The only problem is you go up to bed, you switch it on, and it takes a while to warm up. So you need to switch it on first. And I have a tall house, 3 stories, so it's a long way to go up there just to switch a blanket on. So the solution was simple. We bought a little timer thing. These things cost like €2. You plug it in and you set the time you want to go to bed, and then when you go upstairs it's nice and warm, and that was good. The only drawback of this is it's an electromechanical thing. It goes bzzz all night, which is a bit annoying. So I very quickly replaced it with an embedded system, of course, because my house is full of embedded systems. Nothing clever about these, nothing to do with IoT at this point. This enabled us to set times we wanted to switch the electric blanket on. But that wasn't good enough, because oddly enough, we don't go to bed at the same time every night. Sometimes we go out and we do things, and we come back later. And if you come back at 11 at night and the blanket was switched on at 10 for 10 minutes or something, then it's cooled down again. So we needed a solution to this. And I wasn't sure what the solution was. And then I discovered an interesting product. I should say I have no business connection with the company whose products I'm going to show you. I'm just a happy user. So this is where the Internet of Things starts benefiting Libby anyway. And this is the device I had in mind. This little box, it plugs into a power socket. This is a UK power socket, but you can buy these for continental European sockets and for US ones as well. So you plug this into the socket, you plug your appliance onto the front of it, in my case the electric blanket. You have a little button at the top there, and you can press that to toggle the device on and off. But of course, that's not what you normally do. What you would normally do is open the app on your smartphone, wherever you happen to be. So imagine Libby and I have been to the theatre one evening and we're heading home. We're going to be home in 15, 20 minutes. I'm driving along. Libby gets out her phone, starts out the app, and presses the button, and it goes green, and that says, "Your blanket is now warming, sir." And naturally she would switch on her own as well. But we have individual control. This is the Internet of Things in action. When I told her she was using the Internet of Things, she looked at me as if I was speaking a foreign language, because it means very little to anybody outside of our industry, as you can probably imagine. But I think it's a very good illustration of what the Internet of Things is. I could take my phone out and switch on my electric blanket here, even though I'm nearly 1,000 miles from my home. And I can do it wherever I happen to be, so long as I have an internet connection. Because the device on the left-hand side simply connects to the Wi-Fi in my house, so it is connected to the internet. By the way, I just wanted to mention that to the gentlemen in the audience particularly, I know with Christmas coming, it's very difficult to find a nice present for the lady in your life. I found this to be quite a successful present, so you might want to think about that. But, and sorry, it's sexist. Maybe the ladies might want to think about the gentlemen as well. But, so that's my little hint today. Another trendy kind of device are wearables, smartwatches and these little band things you can wear which keep track of how many steps you've done. You notice I don't wear one. I know how far I move each day. I don't need this electronics to help me. But these are described as Internet of Things. But they're not. I've no idea why they're described as Internet of Things, because typically these will connect to a smartphone, usually using Bluetooth, typically Bluetooth low energy, which is also touted as being relevant to the Internet of Things, but they're not connected to the Internet. The smartphone is connected to the Internet. So they're connected by a very indirect way, but they're not part of the Internet. They don't require an Internet address. I cannot, from my phone here, talk to a smartwatch which is sitting in my house at home, because it would have to be within Bluetooth range. So there's a little bit of fuzziness here about what Internet of Things necessarily means when it comes to these devices. So I'll leave that fuzziness where it is. So what is the Internet of Things? What really is it? I've said the home automation is IoT, wearables maybe not. Well, broadly speaking, the IoT is not a specific technology at all. It sounds like it should be a technology, but it's not. It's really a term we use to gather together a whole bunch of technology. It's mainly used in association with portable devices, but I cannot think of any reason why it should be exclusively, because there can be devices which are mains powered, like my electric blanket controller. That's plugged into the wall. That's not portable. It requires mains power. And that's definitely an IoT application. So there's a lot of fuzziness about what the IoT really is. Now, I've talked to people who are not specialists in our business, and they've asked me to explain what the IoT is. And when I explain this, they breathe a sigh of relief, because they thought it was all a technology that nobody had explained to them, and it was something they were missing out on, whereas actually there's nothing new under the sun, as they say. There are a whole bunch of technologies in the software area which are applicable to IoT. These are all important areas, they're all things that matter. And I just wanted to quickly review them. So we look at operating systems, for example. We might be interested in very compact, possibly hard real-time operating systems. For a very small device, that might be exactly what we want. Alternatively, we might be looking at a full-featured operating system like Linux. We also have an operating system introduced by ARM recently called Embed, which falls somewhere between these two. I'm not going to discuss Embed in detail today, but that's an interesting sort of middle ground. They are pitching it at IoT, which is kind of interesting because there aren't that many IoT devices that sit in the middle ground, but that's another matter. There is connectivity. Bluetooth, Zigbee, Wi-Fi, these are all connectivity technologies. Each one applies to different circumstances. Bluetooth's very good with low energy. Zigbee is deterministic. Wi-Fi requires more power but is more ubiquitous. IPv6 is quite important. I'm going to talk about that in more detail in a moment, just for a few seconds. Low-power design and power management in operating systems is a key technology to IoT because, as I said, many devices are portable, and apart from that, we care about the planet, so consuming less power is a good thing. Security matters because we want devices to be safe in numerous ways, and again, that needs a little bit more thought. And lastly, multi-core design, another key technology, is important because lots of modern IoT devices do have multiple cores. I'm going to poke around a few of these things. Low-power design, first of all. I'm not going to say a lot about this, except that it's a fascinating area where hardware and software engineers have to work together because the hardware ultimately determines the power consumption of a device, but the software has the intelligence to know what the requirements of a device are at a particular time. So therefore an interaction between the two will yield the best possible hardware, the best possible power consumption profile. And the ideal way of achieving that is to use a real-time operating system which has a power management framework, which means the application software has the means of controlling all the facilities provided in the hardware for managing power. Things like changing the frequency and the voltage of a chip will have a dramatic effect on the performance of it, but it will also have a dramatic effect on the power consumption, which is what we're interested in here. So this is an area which is very important in the world of IoT. Security is a great term. People say, oh, I'm very interested in security, and I say, what do you mean? And they say security, but then I say again, what do you mean? Because security means a bunch of different things. People can be concerned about remote hacking of devices. I mean, do you worry about people trying to access your computer from somewhere in Russia or whatever to steal your information? I'm sure you do worry about it to some extent. Well, that's an aspect of security. You can have local tampering. What happens if somebody breaks open a machine and takes the chip out which contains all the valuable data? Well, that's quite important. Another kind of security concern is software malfunction. What if part of the software malfunctions in a way that makes another important part of the software get damaged? Various things we can do, one of which is encryption. We can encrypt data so that anything being transferred across the internet is not decodable. We can do the same thing with data inside the device. So you can store data on a chip but encrypt it all so if somebody steals the chip, well, they haven't got the data. We can protect software against malfunction by using an appropriate operating system. A process model operating system will use a memory management unit to protect one part of the system from another. You may even use a hypervisor, which is an even higher level means of protecting parts of the system, particularly interesting when you have multi-core. And this is what you would use to enable secure execution modes of CPUs that have that kind of capability. And as I said, multi-core is pretty important, and one of the advantages of multi-core is you can segment different parts of the system and make them more bulletproof. You can make one core, you can easily protect one core from another more than you can protect one task from another. So security in itself is a whole bunch of things, very often applicable to IoT. IPv6 is interesting. It's a subject which has been discussed for quite a few years now as being, we're going to need this real soon now. And the Internet of Things is the one thing that really pushes this over the edge, because IPv6 is the protocol used fundamentally on the Internet. The IP protocol, which stands for Internet Protocol, not IP as in intellectual property. Small aside, when I first joined Mentor Graphics many years ago, I didn't know anything about hardware design or EDA particularly, so people were very excited about IP, and I thought they meant Internet Protocol, but they thought they meant intellectual property. So it's confusing, but never mind. The Internet Protocol, the original version, the one that we use routinely, is called IP version 4, IPv4. It was designed in the 1970s. It was designed with enormous capacity, more than it would ever possibly need. You can address up to, in theory, 4 billion devices with IPv4. That's not enough. We're running out. It's also the architecture of it means that we can never use all of it anyway. So IPv6 was invented as a means of solving this. It deals with a number of other little problems, but the most important one is it has virtually unlimited address space. When I first saw this, it made me smile, because I remembered a very famous, wise person, and I'd be interested to, if anybody can tell me who this person was, who said in the early 1980s, these computers have got as much memory as anyone would need. The maximum of 640K is not a problem. We'll never need more than that for any serious computing. Thank you, Mr. Gates. So when I saw virtually unlimited address space, I thought, yeah. And then I actually looked at the numbers, and apparently, if you look at the IPv6 addressing, you could uniquely assign an address to every electron in the known universe and still have address space to spare. I think we're okay with IPv6. We're not going to run out of address space. It has other characteristics that I won't go into, which will also make it an advantage. IPv6 is now being rapidly adopted across the Internet of Things is a major driving factor to that, because the more devices we have, the more addresses we need. The subject of operating systems is interesting because people say they have an IoT-enabled operating system and stuff like that. When somebody says things like that to you, just let them talk, but don't take it too seriously. Let's look at operating systems. If I draw a little graph, horizontally, I have the complexity of my software. On the vertical axis, I have the complexity of my CPU, which is broadly the size of the words it processes. And of course, it can go to 64-bit nowadays as well. I can actually divide this graph into 4 segments. And whether the software is complex or the CPU is complex or both, gives us four regions. And the top right-hand region, where we have a powerful processor with a relatively complex application, is where we will conventionally use either a real-time operating system or a full-featured operating system like Linux. What about the other areas? If we have a relatively complex application but running on quite a small chip, we may still need a simple operating system of some kind, simply because that's a good architecture to build software on, and also as you migrate to a higher end processor, perhaps later on down the line, you want to be able to have a scalable architecture. Similarly, if you have a high-end processor but a very simple application, you might say, well, just run it on bare metal, that's more efficient. That's true, but as soon as your application becomes a bit more complex, you'll need to adopt the use of an operating system. So if you do it from day one, but keep it simple, then your path to a future architecture is much more straightforward. It's only really the low-end processor with a very simple software application where an operating system is not much use, or rarely much use. So IoT could fall in any of the segments on this screen, actually. An IoT device can be very simple, it can be very complex, it can be any level of processor. So there is no such thing as an IoT-enabled operating system per se. There are possibilities in all these areas. I'm going to wrap up with a few conclusions. I've gone fairly quickly, so we are more or less heading towards our correct schedule. My key point is that IoT is not a clearly defined technology at all. It is a general trend. To say it's marketing speak is probably a bit too derogatory, but it is definitely a term which covers a wide range of technologies. It has become what's called a bandwagon. I'm not sure how well that translates, but the concept of jumping on a bandwagon simply means taking up an opportunity to be fashionable like everybody else. You'll have seen in the press, in all kinds of contexts, that everybody supports IoT. Everybody has some kind of support for IoT, but that's both true and untrue, however you look at it. Because supporting all of IoT is impossible because, as I've just described, it covers a vast range of possibilities, and to say you support all of that is just rubbish. If you sell an operating system, you support IoT. If you sell development tools, you support IoT. If you sell almost anything to do with embedded development. So when somebody tells you they have an IoT solution, don't ignore them, but have a look in detail what they're talking about, because they may simply be saying, well, we've got this catalogue of products, we can label this, and this as IoT, and that will make us look cool and trendy. And if you think I'm being very cynical about the state of marketing in many high-tech companies, well, you're right. So it's not a disruptive technology, it's not the great thing of the future in itself, it's a general trend, it's evolution, not revolution. As more things get connected to the internet, we arrive at something which we can call the Internet of Things. It used to be that market research showed that 5 to 10% of embedded devices were connected to the world. We had that number from the early 90s until about 2010 or so. It was 5 to 10% were connected. Suddenly, the 5 to 10% jumped up to over 50%. And that 50% is going to be heading towards 90% in the coming year or two. So devices being connected to the internet means we have an Internet of Things. So it's a true trend, just don't assume it's anything more than that. So thank you for your time this morning. I will be happy to take any questions in a moment. If you'd like to contact me after today, there's my email address. And I also maintain a blog where I talk about things to do with embedded software, or actually whatever happens to be on my mind at any particular time, which may or may not be IoT, depending how I'm feeling at that particular moment.